My name is Lainey Leota, and I'm the Fire Protection Market Manager for Lubrizol. I've been with the company for about 2 years now, I think 2.5 years now. And prior to that, I worked in HVAC refrigerants for a major refrigerant manufacturer. And prior to that, I was with Tyco Johnson Controls for about 5 years in various product management and sales program management roles. Sean, over to you.
Thanks, Lainey. My name is Sean Pierce, formerly Chief Fire Official with Toronto Fire Services, an AHJ and consultant to the province of Ontario for retrofitting fire sprinklers in care homes, consultant to Lubrizol and builders across Canada, the US, and Bermuda. And now I am the Fire Protection Business Development Manager here at Lubrizol.
Sean, go ahead.
My name is John Pritchard, and I'm actually the National Technical Manager for Lubrizol's piping systems. Darren?
Thanks, John. I'm Darren Palmieri. I'm with Viking. I've been here about 5 years now, but a total of over 15 years in the industry. And I've been a part of this, the freezemaster business now for over a year, including helping launch the product last fall. So thanks for letting me participate, Lainey.
Absolutely. Thanks for joining us, Darren, and John and Sean, as always. Thank you for your time today. I'm sure we'll have a great discussion. And speaking of that, we know that everybody is sort of sick of PowerPoints and presentations. I feel like since the pandemic, everyone's sort of been in death by PowerPoint mode. So the way we've been doing webinars lately is trying to have more of a conversation and a discussion, more so than just going through slide by slide. So that's a bit of what you'll see today. We will be sharing slides when relevant if we're going over a chart or something, but it will mostly just be a discussion. So with that said, I will stop sharing my screen now, and we'll only share it when needed. So I think it's important that we just start going over going over why we're even here. Why are we here today talking about listed antifreeze, and for years when listed antifreeze didn't exist. So Darren, if you wouldn't mind, could you go over sort of the history of antifreeze?
Sure. I mean, and feel free. I mean, since we are doing this in a different kind of way, that everybody can kind of chip in as necessary. But antifreeze has got a long history in fire protection. It goes back decades and decades. NFPA 13 standards have referenced antifreeze for going back into the 40s and 50s, I believe. But it wasn't until about 12 years or so ago about that, there was some concerns that came up about the use of what, I usually call legacy antifreeze solutions, which were mostly glycol or glycerin-based solutions, where there were some incidents that it turned out that the antifreeze itself that was in the sprinkler systems when they did operate contributed to fire situations that created injuries and in some cases fatalities. So there was a whole bunch of research after that, after these incidences, and it really changed everybody's mind about where to go and how to go forward with antifreeze. And that's why we're here today, over 10 years later, talking about not just freezemaster, but what is a listed antifreeze and why it's important. So basically, it was determined through a bunch of research that the legacy antifreezes in these systems that had been installed for decades, if they were too high concentration, they could contribute to flammability and combustion. So basically, what was determined was they had to keep those existing legacy systems under certain thresholds as far as concentration, whether they were glycerin or glycol systems. So what NFPA did with this information and the research is they issued a lot of changes. So they issued changes to the installation of new antifreeze systems, and they did that through TIAs in NFPA 13, 13D, and 13R. And then they addressed existing antifreeze systems through NFPA 25. So with the installation of new systems, what they did was they basically said that new systems, and this is generalizing, there's a little more detail to this, but generalizing, new systems were required to be installed with a listed antifreeze. So if you go back in time to basically 2012, 2011, 2012, there wasn't a listed antifreeze. There was no such thing. So for all intents and purposes, what they did was kind of create a ban, so a way to say it, on antifreeze, because there wasn't a product to be installed. And then with NFPA 25, they allowed the existing legacy antifreeze solutions to stay in systems as long as they had met certain concentration thresholds. But they also set a sunset date for those existing systems, which is actually coming up next year, September 30th of 2022. So that's kind of a little bit of the history. Obviously, there's a lot more to it than that, but it's been an interesting past 10 or 12 years when it comes to antifreeze. But now we're in a place where there are listed antifreeze products on the market, and antifreeze now again is an option for freeze protection.
So speaking of that, Darren, you mentioned that these rules were created in 2012, and there was almost a 7-year gap until Tyco came out with the first UL listed antifreeze for fire sprinkler systems called LFP. John, from a contractor perspective, what were people doing? What were fire sprinkler contractors, designers, engineers, and building owners doing instead of using a listed antifreeze in between that period of time?
When NFPA issued the TIAs, one of the criteria for existing systems is you had to use the pre-mix solution after some fire testing was done. As Darren had mentioned, in the TIA in 2012, they had mentioned that you had to use a listed antifreeze that wasn't available. So really, since we at the time were dealing with really an unregulated practice, there was a pause for about 7 or 8 years that no new antifreeze systems were being installed. Just legacy existing systems were being maintained. Contractors had to default to other means. Probably dry systems really became the most prevalent way. Heat tracing was always available, but as we moved along the date line here, UL is actually now required that you have to have UL listed heat trace for sprinkler systems. So dry systems probably was the most prevalent system used for freeze protection in that window where antifreeze wasn't being used for new systems.
Thanks, John. So next question that I have is, why did it take so long to come out with the listed antifreeze? And Sean, why don't you go ahead and address that question?
Thanks, Lainey. So, probably the biggest issue is the listing with the development of the listing definitely slowed down manufacturers coming out with something. But beyond that, once the listing was created, and you can see on the slide, it had a number of different components. And it wasn't just exposure to fire, which really was the primary goal. We wanted to make sure that any antifreeze we put in a sprinkler system wasn't going to contribute to a fire, make it more dangerous. In the case of legacy antifreezes, as Darren described them, they would, the fine droplets would actually ignite all at once, causing an explosion and potentially harming life. So you have that whole fire exposure to fire test, and that's that blue column from where I'm looking, it's on the far right. But as well as we had to pass a number of fire fluid performance tests. So high ambient temperature stability. Does the material stay a homogeneous mixture if it's exposed to high temperature? When you think about, middle climates where you have cold winters and warm summers, that's really important. That fluid's going to stay in that black pipe over the summer, potentially outside, and it's got to maintain its stability in high temperatures. temperature cycling. So summer, winter, you have to maintain stability with temperature cycles. Electrical conductivity. How conductive is the fluid? Corrosion. This is a big issue. Corrosion is a huge issue in the fire sprinkler market, and the antifreeze products couldn't contribute to corrosion as well. Exposure to elastomeric materials. So this is part of the chemical compatibility component of this testing. The gaskets that are used in grooved fittings, gaskets now, and head adapters. The material has to be compatible with all of those materials. Toxicity. So in the case of freezemaster, it is a non-tox solution, but you have to fall within the parameters of the UL 2901 test. Resistance to leakage. When you're temperature cycling and the pressure goes up in the system, will it sweat antifreeze out of the heads or not? And so that's a component. Viscosity at its temperature limitation. So at its very highest potential temperature and at its lowest operating temperature, does this material stay viscous? Will it flow through a sprinkler system? Then there's the characteristics test, and I went backwards. I started with fire because it was the focus of it. Pour point, viscosity, specific gravity, pH, freeze point, and then the minimum use temperature, which isn't on here, but that's where the temperature you see on a bucket of these new listed antifreezes isn't the freeze point. It's the minimum use temperature, which is generally 2 degrees warmer than the freeze point, so that as a contractor or a property owner, that the fluid will flow as it's designed at that temperature. It doesn't. There are no ice crystals forming in the material at all at its minimum use temperature. So it's the safest position where that you can use that fluid and it'll operate as it's designed. So when you put all of these components together as part of UL 2901, and then battle viscosity, which is, I think the biggest issue we have with listed antifreezes, to achieve all of this, your viscosity goes up, and now you're facing other challenges. So I think everybody in the market, including ourselves, we fought viscosity while achieving all of these components of UL 2901.
Great. That was a great explanation, Sean. Thanks so much. And now that we are into talking about listed antifreezes and what all is required in a listing, I think it might be helpful to take a look at and discuss further the differences between a listed antifreeze and an unlisted antifreeze in terms of how you deal with them in systems and things like that. So Sean, do you sort of want to start out in talking about, the different nomenclature, like you mentioned, minimum use temperature and freeze point was one. What are some of the other considerations and terms that are used for listed antifreezes that might not have been used for unlisted antifreezes?
Yeah, I think that it's really important to look at the fact that this is now a listed product versus an unlisted product. And as part of that, you go through all those tests, but as well, you have minimum use temperature. So in the case of freezemaster, we're minus 12F, minus 24C. Freeze point, we're minus 15F, minus 26C. The material will still pour, it will pour at minus 22 degrees F, minus 30C. And its burst point is minus 58 Fahrenheit and minus 50 degrees Celsius. So like legacy antifreezes, all of this kind of plays a role. The minimum use temperature is unique to listed antifreeze. No one has applied that to a legacy type fluid. Freeze points are similar, but you'll notice that the minimum use temperature is considerably warmer than the burst point or pour point, and this is all part of it being listed. And I'm going to steal a comment from John, my colleague here, who when he talks about antifreeze, he says it's like using a listed sprinkler head. So you purchase a sprinkler head based on its listing, it's going to perform in a specific space, with specific coverage at a specific pressure. Antifreeze has now gone from completely unregulated to fundamental to listed, similar to a sprinkler head. And each antifreeze has a different listing, and I think it's important we recognize that. So, depending on what you're looking for, you have to check the antifreeze, check that material data sheet, check the install guide, and that's a critical difference between legacy and now listed antifreeze. Is the listings are different as well. The passing UL 2901 doesn't make everybody the same. Follow the install guides, make sure you're using the products appropriately and you're getting the best one for your application.
Thanks so much, Sean. Appreciate that. So next, John, would you mind going through some of the other requirements that a listed antifreeze has that unlisted antifreezes, that weren't considered with unlisted antifreezes, like the volume limitations? I'll switch my slide here, and if you wouldn't mind going over that specifically for freezemaster antifreeze, that would be great.
Yeah, and I think Sean alluded to, this is an important part, that we now have regulation for the use of antifreeze, and there's specific guidelines in your design criteria that needs to be followed. Now, for 13D applications, you have a 500-gallon limit, which for a 13D, that's going to be a very big home, so I don't think that's really going to be an issue. For your 13R, you're also going to have that 500-gallon maximum limit, but if you have in that 13R occupancy, if you have some areas that are going to require a 13 design, such as attics or parking garages, you're going to have to default to the NFPA 13 requirements, which are, you have a 200-gallon maximum limit before you have to start putting in some different design criteria. So when you go over 200 gallons, from 200 to 500 gallons, you're going to have to use dry system hydraulic calculations. And we're going to ask you to use Darcy-Weisbach because it's going to have you figure in the viscosity of the liquid that you're going to be dealing with. And we mentioned, Sean mentioned that every listed antifreeze now has specific requirements, and this is probably a big one, ordinary hazard group 1 and 2. Currently, freezemaster is the only antifreeze available that's listed to be used above 40 gallons. We actually have a 375-gallon limit, but with that being said, you're still going to have to use the dry system hydraulic calculations, and that's going to have to be figured in. So with existing systems, it's not a direct replacement. You're going to have to maybe think about recalculating your existing systems when you get to these large gallons systems to make sure you're complying with the specific listings of any antifreeze that you're working with.
I'll add, John, that from our perspective at Viking, from selling the product and dealing with a lot of end users so far on this, that the limitations haven't been a big hurdle for us. So you think about 500 gallons, like you mentioned, these are large systems. 500 gallons is a lot of antifreeze. It's a lot of liquid to fit into a piping system. And now with the ordinary hazards groups 1 and 2 expansion to 375, that just opens up more opportunity to get a listed antifreeze either in a new system or as replacement. So even though we call them system size, sometimes we say that these are the limitations, but really the limitations are pretty good and work for most situations.
And I think on that, a question that comes up a lot is in the cases where you do have a system that is larger than 500 gallons or 375 gallons or whatever occupancy you're in, can you still use listed antifreeze? Like, can you valve off systems into separate smaller systems in order to be able to use a listed antifreeze?
I'll answer that because there are some that legacy systems that are over 500 gallons. So this is where, I use the example that it takes a village, that you're going to have the AHJ, the contractor, the building owner working together to possibly have to retrofit and do some design changes to the existing systems. It may be something as simple as breaking the system into 2 smaller systems. a system's definition is really just a water source or antifreeze, an alarm or flow switch, some kind of alarm, and a drain. So those are the ones that right now that probably are going to be the toughest to struggle with. But as we get through the sunset date and we get all these existing systems up to date, you are now going to have a viable alternative for freeze protection when you use antifreeze.
Thanks, John. And a very interesting question that just came in through the chat that's definitely relevant to this slide. And it asked, and Sean, I think you're the perfect person to answer this question because I know how you feel about it. Why would you use a dry system calculation if there isn't a delay due to water having to fill the dry pipe?
So it is a requirement that UL has placed on listed antifreezes. It's a great question. I agree with the concept of where the question is coming from, and standards, listings, building codes, as we all know, aren't permanent, and so we are working to address that right now. The concept is that water is the ultimate extinguishing agent, and so they want to basically figure out how long it's going to take for water to get out of that sprinkler head. Delivery time software, there's so many options out there that you can look at to take advantage of that. And I think that the 2901 hasn't addressed that as of yet, but it's something I think that's coming in the future to help overcome that exact thought process. I share your thought process, whoever asked that question.
I'd like to add something there. This is really a new standard and there's some safety factor built into it. And the thought process is, you want to help evacuate some of that, antifreeze because it is thicker than water. So that was probably the original thought process. As we move forward, like Sean said, this may change as the standard evolves.
Great, thank you. So we've talked a lot about system volume per occupancy and things like that. Are there other considerations that we need to make in terms of specific design criteria that we should be considering? Sean, why don't you take that?
Thanks, Lainey. So, there's, because of the viscosity issues, and you heard me talk about viscosity early on, you're seeing these higher operating pressures that are being required. You may have to, there's definitely the potential for, when you use those dry system calcs, there's a potential for having to upsize riser pipes getting into an attic. You have a 13R application. There's different things you're going to have to look at. The minimum design pressure, I know that the LFP Plus has a minimum operating pressure of 20 psi. Ours doesn't, but again, we're all fighting viscosity with listed antifreezes, and so it's a tough conversation to have. One of the first things I said, we went from having really no standard at all the way up here without a step process. We went from nothing to fully listed, and when you're talking to customers or as an engineer or designer, whatever the case may be, it's a hard sell to explain to people why you may have to upsize a pipe or some of the other things you're going to have to do when you look at using the dry system calcs or the minimum pressure requirements. But these listed products are fundamentally safer. They've been tested to be safer than the legacy products, so they're going to do what NFPA and UL and everybody else involved in this conversation set out to do. It's a tough conversation. It is a requirement and something that you have to follow through on. And John pointed it out. I pointed it out earlier. I think Darren did too. You've got to follow the listing. You've got to check each install guide. Make sure you're following the rules for that particular material and how to install it. And making sure that the system's going to operate properly because the fluid's being calced, and it's going to deliver as intended.
Great, thanks so much, Sean. So still talking about the differences between listings and unlisted antifreeze. From a testing standpoint, John, can you go over the differences there and what contractors and engineers might have to do differently from before when dealing with a legacy antifreeze?
And this is another big change that contractors have to be aware of. Historically, we have tested antifreeze, whether even something as simple as your car antifreeze, with a Fahrenheit or Celsius testing apparatus. That's no longer applicable. So a lot of contractors, especially ones that do inspection and testing, are going to possibly have to upgrade their testing equipment. You are now going to have to test the specific gravity, which is specific to each listed antifreeze with a hydrometer, or you have to test within a refractive index, and they give you a little bit of play between that, but you're going to have to use a refractometer. Currently, a lot of companies' testing equipment is not viable and doesn't work. We've had numerous people that have actually called us and tested with Fahrenheit. With the listed antifreeze, you will not get a true reading. Though our antifreeze, for example, is listed as a glycerin-based, every antifreeze available today is really proprietary, so you won't get a true reading if you're using legacy Fahrenheit Celsius testing. Surprisingly, we did one thing that was very well received as we colored our antifreeze. Typically antifreeze comes clear. It's hard to tell if it's propylene glycol or even glycerin. Where we designated a color to ours, it at least gives the installer, they know now that if you're using our colored antifreeze, you know what you have in the system. I think moving forward, it's probably behooves anybody with a listed antifreeze, and it'll really denote what type of antifreeze you're working with in that sprinkler system.
Thanks, John. And Darren, working for Viking, do you guys have those new tools available, or the tools that you should be using with freezemaster?
We do. Obviously, in addition to selling freezemaster through Viking SupplyNet, we also offer the tools required to test them. This came up, just as John mentioned, when we first started selling the product, that we realized that the existing tools that most of the contractors had were not going to work out with freezemaster. So we went ahead and built relationships with a couple manufacturers now to supply the correct refractometers. So we're able to provide the product itself and also the tools they're going to need to test the freezemaster.
Great, thank you. So we've talked a bit about the differences between how to deal with listed antifreeze versus unlisted antifreeze, and a little bit about freezemaster in particular. Now, Sean, you mentioned something earlier about how antifreezes, are listed almost just like sprinkler heads, or sort of similar, where each antifreeze is listed for different applications and things like that. Can you go into a little bit about the specific listings that freezemaster has?
Yeah, for sure. Thanks, Lainey. So freezemaster is unique in a couple of different ways. John touched on our volume limitations, which is probably the key thing to think about when you're looking to differentiate using one product over another. But some of the other differences is freezemaster has a unique corrosion package as part of the product that we've been able to all but eliminate corrosion in sprinkler systems, unlike some of the other products on the market. In a couple of IP tests for corrosion protection, freezemaster had 0% corrosion development, whereas other listed antifreezes had as much as 65% corrosion development. And that's I think one of the big differences. We also if you're using it in galvanized piping, in a sprinkler system with galvanized piping, freezemaster is listed. That's a component of our listing for use. You can use freezemaster in galvanized piping. Currently, the LFP products are not listed for use with galvanized piping. All of the system accessories I talked about earlier, EPDM, butyl rubber, natural rubber, nitrile, styrene rubber, all listed, and we're approved for use with all of that. So pretty much every gasket material in the marketplace, you're going to be okay with freezemaster. John and Darren both talked about testing. It's important that you use, I can't stress this enough, it's really important that you use a good testing device. A car radiator antifreeze tester just doesn't work. These materials are super proprietary. In the case of freezemaster, it is a mixture of materials to achieve all of the goals of UL 2901. It is not exclusively glycerin or glycol. It's a component product in order to achieve the listing as every other listed antifreeze is in the market. So you can only test refractive index, and making sure you're using the right device for that and doing that is critical as well. And it is part of the listing to test only to refractive index. So I don't know if anybody's got anything else they want to add, but
I'll touch on what John brought up as far as the fact that the product is dyed. The feedback we get from our customer base, the users of the product, is very positive on that. So it's a really nice feature to be able to tell that it's a freezemaster product that's installed. You don't have to worry if the tag's been taken off the system or replaced. If you see the blue color liquid, you have a freezemaster system. So I didn't think a whole lot about that feature before launch, but since I've received some feedback from the field, I'm very positive that's helping our customer base for sure.
Absolutely, and it is kind of cool with such a new product, not only in freezemaster, but just listed antifreeze being relatively new anyway. We as Lubrizol and Viking have learned so much since the launch of antifreeze, things that we would have never even thought to address, or things that we didn't necessarily realize were benefits that are benefits, and things like that. So it's kind of cool learning new things every day, and getting new questions every day, and figuring out the best way to deal with them and answer them. In fact, yesterday we had a presentation with SFPE that was titled "What We Learned Since the Launch of Listed Antifreezes," and that was kind of cool to talk through. So
Lainey, just on, Darren brought up color, and just the primary rationale for us to add color early on was that when you fill an antifreeze system, your drain port is open on the far end, or your test points every 100 feet. If the fluid isn't colored, you don't know when antifreeze is starting to come out of that system. So in theory, you could be wasting and having to recapture a whole bunch of fluid that you don't want to waste. These listed products are definitely more expensive than unlisted. And that was the concept was that when you start to see blue, you've got antifreeze coming out of that system, and it's time to start using your refractometer and testing to see what concentration you've got. And that was the primary reasoning, but the color seems to have gone well beyond that.
absolutely. So let's move on to designing listed antifreeze systems. I know we talked a bit about the differences, but let's go into detail a little bit more, specifically as it relates to temperature. John, do you want to take this one?
I think we've discussed today that viscosity plays a huge part in the design factor, and viscosity plays a huge part in actually the temperature and end use of the material. What you're seeing right now is actually the lowest one-day mean isotherm chart, which is in the appendix of NFPA 13. This isotherm chart is used in many different industries, but you can see our listing right now is to -15. As you can see, that doesn't cover all of North America. And when you're designing a system, this is just a guide for you to think about in your design criteria. And there's many different things that you should have in your criteria. Is the piping exposed to wind chill? Wind chill is can be very tough to deal with. If the pipe is directly exposed, that temperature is going to be a lot lower. You know, is the building structure that you're dealing with have some residual heat? Example, a loading dock. You know, some loading docks are usually the doors are closed in the winter months. They use antifreeze as a safety factor. Is that temperature really going to be what the exterior mean temperature is? Now, if the loading dock has the doors open all day, that's another concern. So there's a lot of factors that you can think about in your design, and really that chart, you can actually, if you have some benefits from residual heat, even in an attic, let's say, I was in one, we were redoing a clubhouse, and they actually were using that attic for some storage, and they had some residual heat in there, so they were comfortable with the application. So when you're designing your system, especially if you're along that line where our temperature is, there's a whole bunch of factors you should consider in your design if you are going to use our product.
Yeah, and I think that kind of goes for any listed antifreeze that, there is a minimum use temperature, there is a freeze point for good reason, but just because you might live above the line of, that specific freeze point or minimum use temperature doesn't mean you need to rule out the use of, whatever listed antifreeze, especially if you're dealing with a conditioned space. So I think that's definitely important to realize, as there are some parts of the country, in northern parts of the country or, into Canada, where a listed antifreeze solution does not currently exist. So if you're dealing with conditioned spaces, I think that's very important to realize. So did anyone have anything to add to that before I move on to expansion?
I think,
Oh, sorry. Go ahead.
no, I think that's a really important point that both of you made, that, we do try to actually draw this line, right? Because there is a line, but every system is different, and you need to look at the individual system to determine if antifreeze is an appropriate means of freeze protection, right? So just because there is a line and it's a helpful thing to kind of know, you really need to take a look at each system and make that determination individually.
Absolutely. And actually, I just thought of one question that always comes up is not that you should be installing antifreeze that isn't listed for, that particular temperature, but what do you do if the temperature goes below the minimum use temperature in an antifreeze system? A listed antifreeze system, do you have to drain and refill it? Sort of what will happen?
So, Laney, I'll answer that. The fluid's designed, we talked earlier about the 2901 test and temperature cycling. So the fluid's designed to be even frozen and returned to a homogeneous state. So the fluid will be completely fine. However, if you're in a situation where the building temperature has dropped below the minimum use temperature, it's important that other means are taken as well, that a fire watch be established or something to that effect as per your local authority's requirements. But the fluid will not be, its performance in the future will not be affected in any way. If it was to freeze and thaw, it's designed for that.
And I think what is important to note too is that what John went over is the isothermic mean temperature. So just because, your system could get down to negative 20 something or, negative 30 something for, I don't know why that automatically changed by itself. Just because it could get down to a lower temperature for, 5 minutes or 15 minutes or an hour or whatever does not mean that, the antifreeze can't be installed there, or that you won't have necessarily a functioning system. It needs to be very cold for a sustained period of time to get to that burst point, or for it to completely start freezing.
Yeah, and I think the majority of systems going in right now, there's a lot of large systems out there in the marketplace, but there's a lot of tail end systems in partially conditioned spaces, like everybody else, kind of mentioned before. And those partially conditioned spaces, the antifreeze is there purely as an emergency. The garbage room of every condo, the first 5 or 6 sprinkler heads in the entrance to an underground parking garage, all those tail end loop systems. When you look at, regardless of where you are, even up here, I'm in Canada right now, our product would work perfectly well in that environment because the doors are only open for 10, 15 minutes at a time, and the antifreeze is there to protect in the event a fire were to occur when the doors were open. But the heat comes back on and the space warms back up again almost instantly. So when the doors close. So that's I think that's a critical thing to consider. When don't get tied directly to that chart too much. Think about your application.
So when sort of moving on to expansion, first of all, are expansion tanks required with antifreeze systems or listed antifreeze systems? And how do you account for it? And is it different from unlisted antifreeze? Sean, do you want to take that one too?
Yeah, so there's lots of options in NFPA 13 around what you can do with antifreeze systems. NFPA, unfortunately, hasn't really kept up with what UL is expecting when it comes to antifreeze systems. And so when you think about the cost differential, listed antifreezes are more expensive than legacy type solutions. They inherently, you want to try and capture it rather than let it bleed out of a relief valve or something like that on a system, which is, these are all options in NFPA. And so the expansion tank really is the best solution for that. And so that's why we suggest it. When a system is going through temperature cycling, summer, winter, in the summer months, that pipe, think of a garbage compactor on the exterior of a building. It's going to have a couple sprinkler heads on it. And that'll be an antifreeze system, a loop. If you don't have an expansion tank, that sun will beat down on that black iron pipe. It'll heat it up. It'll expand. One of the options was drilling a hole through a check valve to allow pressure to relieve and for unlisted fluids. But if you do that, you're diluting the mixture. And so with unlisted product, with that legacy product, you could top up the system with antifreeze in theory to bring it back into spec. Well, you can't do that with listed product. It is pre-mixed. There's no way to buy raw material. It's a proprietary composition material. So you're stuck at that point having to drain the system and theoretically refill it. So what the expansion tank's going to do for you is it's going to allow fluid to go into the expansion tank before the backflow. And as the temperature drops, the air pressure on top of that bladder is going to push that antifreeze back into the system, stopping you from having the system diluted by water passing through the backflow. And so while expansion tanks can be expensive, they can be frustrating to size sometimes and set the correct air pressure above the bladder. They're ultimately going to save the property owner money because you're not going to have to drain and refill a system. And when I talked earlier about we went from 0 to here with listed, this is one of those things that you got to think about and take into consideration when using listed product.
I'd like to add something here. Now that we've launched and had our product on the market, this is probably one of the toughest conversations we've had with contractors with existing systems. The aversion to the cost of an expansion tank. A lot of guys use the option of drilling a hole in a check valve, which worked for the expansion portion. But when the material contracted in the winter, that's when you were diluting the system. So for people doing inspections and maintaining existing systems, this is an important message you have to have with your customer, that existing systems may have to be retrofitted to keep the system from being diluted. Expansion tanks are an option. They do have the option to use a relief valve, but they also make mention that you capture that liquid and repump it back into the system. That may be a recommendation for some of these larger systems, and it is a viable option. But keeping the system homogeneous and being diluted is a very important detail one needs to have a discussion and really make sure existing systems are going to be compliant.
So why can't you mix antifreezes? Can you go in a little more detail about that? Like, why can't you just top off a system, with either a listed antifreeze to an unlisted antifreeze or a listed antifreeze to a different listed antifreeze?
So they're each a proprietary mixture, each on their own right when it comes to listed antifreeze, and they're listed as they come out of the pail. So if you top it off, it's no longer that listed product. So its performance from a fire perspective, conductivity, compatibility, all of those things will absolutely get called into question. And again, this is that step that we missed. We went from nothing to fully listed, and we missed steps that we normally see in this industry along the way. And so that I understand that everybody's, it can be a struggle. It's hard to talk to your clients about this huge price increase and what's happening right now going into next year. But the reality is it happened because we unfortunately had injuries and fatalities related to fire protection antifreeze. So the products can only be used on their own. Diluting them with water affects their performance. Mixing them with something else affects their performance. And their performance is based on the material being tested, freezemaster being tested as it is when you get it in a pail.
And so a question that comes up, and it's been asked in the chat quite a few times, is do you need to drain the drops? And I know that this is a very, I guess, a very hot topic of conversation that there's various opinions on. But Sean, what is sort of our view on it and why?
So this is a really challenging space, this concept of draining drops. And if we go back to what I just said, if you dilute a listed product with something else, it won't perform the way it did in its listing test. Just like if you install a sprinkler head that's 12 by 12 in a 20 by 20 space, it won't cover 20 by 20. There's nothing you can do to get it to do that. It's not designed for that. And so there's currently there's an annex statement in 25 that we refer in our install guide that says, drops shorter than a certain height don't need to be drained. UL has a slightly different perspective on that. In their mind, the system must be fully drained to ensure that there's no dilution or mixing of the product. So as of right now, and I think this is one of those things, John talked about it, there's an evolution of UL 2901 happening, and this is one of the areas that's evolving right now. So it'll be interesting to see in the near future where that ends up. Commonly either removing a drop, if the problem, of course, with removing a sprinkler head, if you remove it to drain a drop, you have to replace it. That's a potential additional cost, and we understand that. If you could pull the drop out of a T or a 90, that would be a better option. But I think the best answer is right now our install guide says follow NFPA 25, and if you use the annex statement in 25, there's some leeway there. I believe that this is going to change in the near future, that UL is going to step in and they have a slightly different view on it than that.
Thanks, Sean. I think that's a really good description of it. I think the last question that we get before we move into the Q&A portion and address those questions we haven't already gotten to is how do you dispose of freezemaster antifreeze? Darren, why don't you take that one?
So yeah, this one does come up pretty frequently, right? Because obviously there's going to be a chance where the product has to be taken out of the system and then disposed of. So it's basically per local requirements. So the local jurisdiction, the local city, there might be state or city or town rules. But what we do know is that you simply just don't dump it down a drain. that you actually have to remove it and contact the local jurisdiction to find out exactly what they require as far as disposal.
Great, thank you. And lastly, while we're on, or while we have you talking, is can you just go over how the package sizes that Viking sells, whether or not you have a minimum order quantity of freezemaster, etc.?
Sure. So we do sell it freezemaster through Viking SupplyNet, our locations. We have them in 3 different sizes. So we have 5-gallon buckets or pails. We also have drums that are 55-gallon drums, along with larger totes that you can see in the picture there behind the pails. They're 275-gallon totes. And we are currently selling all sizes. So it depends on the application that the contractor has, that they decide what size they need. And we are stocking the product in all of our locations. So we do have the product on hand. As far as minimum order sizes, we'll sell anything. So if a contractor comes in and needs 1 5-gallon pail, they can walk out with 1 5-gallon pail. So if they need a pallet of them, or they need 10 totes, they can get any quantities they need. There are the hang tags that go along with it. So NFPA does require that antifreeze systems be tagged as antifreeze systems. And you guys have developed a really nice freezemaster specific tag to put on the system to add all of that information that's required and have room for information as far as the testing and maintenance of that system. And those ship with the product. So when people come and buy the product, those tags are available with the packaging itself.
Thanks, Darren. So we have about 7 minutes left, and I'd like to take that time to answer some of the questions that we did not answer quite yet in the chat. I know we got to a lot of them verbally, but there were some that still are left over. And if you have any other questions, now is the time to put them into the Q&A. We'll start out with, we'll go back to the draining of the drops. And I just lost it. It is, when you drain the drops, and do you flush them with water, or can you just drain them and then just refill it with a UL listed antifreeze?
So, the problem with existing systems is it's not just the antifreeze in it. There's years of built-up corrosion and potentially mic in that system as well that could affect the performance of a listed antifreeze. So it is suggested to flush, but that's not a requirement anywhere. I think, if you're a contractor and you take a system apart to replace antifreeze and you find a lot of other material buildup in it, I would seriously think about putting something back in a system that doesn't look good. If you drain a drop and you can see inside that pipe and it looks good, then act accordingly. I think that's the best answer. And when you're doing this, I mean, this is I know it's a struggle when you're dealing with long-term customers and you're giving them bad news, but I would suggest that part of this is part of that internal investigation requirement, and if you find something, I would really think about replacing pipe if it looks real bad, because that too, all of that mic and all those other byproducts of corrosion will affect the performance of listed antifreezes.
Great, thanks, Sean. Next question is sort of, I think, opinion. What is your feeling on using a listed antifreeze in a 13D system when it probably will never be tested after installation?
So you're right. It probably won't ever be tested. I know some insurance companies are asking for some form of testing on 13D systems. now. And really, I mean, what are you going to do? You're going to go in and do a bucket test or something? Potentially you could do that, or you're just going to go on and go into a home and make sure the valves are on. So your statement is 100% accurate. It probably won't get tested. It should. There should be, because antifreeze isn't governed in 13D, but it absolutely should have an annual inspection on the antifreeze portion of a 13D installation. But what you're saying is a reality, and in a residential system, in a new installation like what it sounds like you're describing, I think it's just a component of what 13D is, and I don't really have a great answer. I think the right answer, we know what the right answer is, but what this person's suggesting is an accurate problem.
I think it's just a problem with residential fire sprinkler systems in general, not even just antifreeze systems.
Yeah, and I don't know that if it's a problem per se, because we want to install 13D systems so people don't have added expense, right? So it's a balancing act with 13D. There's absolutely no question about that.
Yeah, I would just add that, while there are certainly applications that the antifreeze product will help solve for 13D, because of this lack of having a listed product for many years now, that many designers, many installers have come up with other ways to avoid those types of issues. This issue right here. So, it'll make sense in some situations, but there are other ways certainly to freeze protect in a lot of single family home applications.
Thanks, guys. One other question that we had is what is the life cycle of freezemaster in an antifreeze system if there is no dilution? I think typically we estimate about 5 to 6 years. Obviously, it depends on the system. I don't know if you guys have any.
Yeah, no, Leanie, I think you got that answer accurately. I mean, if you've got a system with a lot of corrosion in it, that could affect it. If you've got a system that isn't a very tight system and it's leaking in different places, or it's previously had something in it that caused corrosion, you've got pinhole leaks, and you're drawing water through your backflow, that's going to affect its lifespan. But if you've got a brand new system, you've put freezemaster in it with our corrosion package, 5 years is, I think, a very easy. The shelf life of it is easily within 5 years. So I can't imagine having any issues in a brand new, well designed, well put together system. 5 years would be a fair estimation.
And sort of on before it's even installed, does the product have a shelf life? Like, can someone keep stock on hand without it degrading?
Yeah, we have a 5 year shelf life on it, and I don't, Darren, you can answer that. I don't think you've had any of it sitting around long enough to see its shelf life, have you?
No, I mean, in fact, we only started selling it in September of 2020, so we certainly haven't hit that yet.
Great. Next question is, what is the name of the specific tool they need to use to get the temperature reading when expecting antifreeze?
Well, there's two ways of testing. You could use specific gravity, which would be a hydrometer. And then if you use the refractive index, you'll have to use a refractometer. They're sold by multiple manufacturers. We've mentioned Fisher, I believe, Reichert. That would be a good thing to consult your local Viking rep or Viking distribution if you have questions, or they could contact us and we could send them various manufacturers as well. Another one on the market that many contractors have is Misco. That's one I would check with Misco themselves to make sure you have one that can read refractive index.
Great. And one last question prior to us logging off is, I just lost it again. Sorry, 1 second. For expansion tanks, do you use the charts for glycol or glycerin or a separate chart for freezemaster? And I can actually answer this one because I just had this conversation with Amtrol, is there is actually a separate chart that you should be using. And they just haven't published it yet. But if you need help with that, you can reach out directly to them. The same thing goes for FPPI. It is very similar to, is it the glycerin one, Sean? Or is the glycol one?
Very similar to the glycerin one.
The glycerin one. It's very similar to the glycerin one. There's not a huge difference, but you still should be using, a chart that is unique to the listed antifreeze, and that chart will likely differ among the different listed antifreezes. So I know there are a few questions that we did not get to. We promise that we will follow up with you shortly after the end of this session, sometime this week or next week if you're not on Thanksgiving holiday, and get your questions answered and work through some of the issues that some of you might be having with either listed antifreeze or unlisted antifreeze. I'd love to thank the panelists, John, Darren, Sean. Thank you so much for having this conversation with us today. I'd like to thank the attendees and extend a great holiday to everybody, and again, always feel free to reach out and let us know if you have any questions. So thank you so much everybody for coming, and I hope you have a good rest of your day.